moving on to the next column, let's start using these properties. In this first property we have x is being multiplied in the base, but we're going to add exponents and have x to the 12th. In the next problem, you don't see it, but there's an understood x to the first power on the third term there. So when we multiply, we're going 5 plus 7 is 12, plus 1 more makes 13, and we're going to have x to the 13th power. In the next problem, it's very tempting to say 25, but it's just 5 to the 17th, not 25 to the 17th. And if you get confused on that one, let me show you. If it was x to the 6th times x to the 11th, you'd have no problem seeing that that would be x to the 17th. Well, instead of x's, you have a 5 here. The 17 just refers to how many x's are being multiplied together. Same thing here. This is how many 5s are being multiplied together. In problem D, we see division, which tells us to do subtraction. 14 minus 9 makes 5, and so we have x to the 5th. Sometimes instead of referring to subtraction, I like to say that this fraction is top-heavy. There's a higher degree in the numerator, and so I'd like to say it's top-heavy by 5, and that's what gives me x to the 5th. In problem E, we're going to split this into several problems and work on one variable at a time. When we look at the x's, we see that there are more x's up in the numerator, and 6 minus 3 is 3. It's top-heavy by 3, I'd say. With the y's, y to the 11th over y to the 7th, there are 4 extras upstairs. We have y to the 4th. And with the z's, there's also z to the 2nd, 2 extras upstairs. I really don't need that over 1 anymore. I can just write that as x cubed, y to the 4th, times z squared. In problem F, we have a large expression to the 0 power, and we said a moment ago, anything to the 0 power, no matter how messy it is there, is equal to 1. And this is where it starts to get a little tricky. 3x to the 0 is not equal to 1. That 0 power only goes with the x there. This is really 3 times 1, which is equal to 3. What you were probably thinking of is what I've got written here in problem H. That quantity is all to the 0 power, and in that case, it's equal to 1. Moving on to letter I. Here we have a negative exponent. There are two ways to handle this. You could say negative 4 minus 2 makes minus 6, and then x to the minus 6, because it's a negative exponent, moves down to the denominator as x to the positive 6. Or you could just say these 4, because of the negative exponent, come downstairs. We have a placeholder of 1 upstairs. X squared times x to the 4th down below gives us 1 over x to the 6th. On problem J here, I'm going to deal with one variable at a time. With the x's, that x to the minus 2nd travels up to the numerator, giving you x to the 5th up above in the numerator. And with that y to the minus 4th with the negative exponent, it moves down to the denominator. Those 4 y's come down, join the 8 that are down there, giving us y to the 12th in the denominator. Now, if you don't like that movement the way I've done it, you could have used subtraction. We could have said 3 minus a negative 2, and whenever you minus a negative, you get addition, so that becomes 5. Negative 4 minus 8 makes negative 12, but we move that negative 12 downstairs to the denominator and make that a positive 12. No matter what, except for the case of scientific notation, which we'll be learning later, negative exponents are not considered to be simplified. Therefore, we do not leave them in our final answers. That's why I could not leave y to the negative 12th in that last problem. I had to make it y to the positive 12 down in the denominator.